Okay, let's look at this problem. Problem number 1155, number of dice rolls with targets. So in this problem, we are given three integers, n, which denotes the number of dices, k, which denotes the number of face. So each dice will have face numbered from 1 to k, and then we have target, which is what we want to achieve after rolling these dices. So let's say we have three dices, and for after rolling them we get 1 1 2, then the sum is equal to 4, then this is one of the possible answers. Okay, what is the total possibility which we can get from these three dices? So it's k to the power n, which is uh, from first dice, let's say this is 6 face dice, so 6 into 6 into 6 is the total possible outcome. So we have to find out what is the number of outcomes which from which we can get the target for in this problem, that is 4. So these are all the three total outcome which we can get, so that the sum is equal to 4. So how we can approach this problem? So since in this problem we are asked the number of possible ways, one of the way to go is to try all the possible outcomes which we can get. So means trying all the possibilities. So let's say you take one dice and see what all possible outcome you can get from that particular dice. And after so let's say we roll one dice, and these are the 6 possible outcomes which we can get from that dice. And then after rolling the dice, we let's say we get number 3 here, then our target is reduced by 3, then the new target will be target minus 3, and the number of dices has also reduced. Now we have a sub problem in which the number of dices is reduced by 1, and target has also reduced depending upon the outcome of the first dice. So what we are trying to do is finding all possible ways, outcomes which we can get from dice 1, um, and checking if that outcome is possible or not. So in if the target is 4, we can see that not all phases can lead to a solution. For example, this k is equal to, so if the phase is 4, 5 or 6, then um, it is not possible to get an answer from the remaining two, because you cannot have zeros on that remaining two dices or negative. We are constrained that n is k is greater than 1, equal to 1. So effectively roll a dice and then solve a sub problem in which after each roll you have one dice reduced and target also reduced. How do you check if that outcome is possible or not? You just check if this number, let's say 6, is less than target. We check that. So target is 4, no, then we don't go through this path. 1 is less than target, yes, then we can go to this path. Now let's look at the base case. So what's the base case? So when we have a one dice, there is only one possibility, that can we achieve that target or not. So there are two ways it can affect the outcome. So let's say when k is the number of faces, or a number we can get, maximum number we can get from one roll. So if that k is greater than target, then we have answer yes, we can get one answer, get a solution here, and also the number of solution is 1. So from one roll, if we have a target and it is achievable, the number of way to get it is only 1. And if k is less than target, then the output should be 0, because we cannot achieve that. So effectively what we have done here is created a subproblem, created a base case, and then we can solve it recursively. And to reduce the time complexity, we can use memorization for storing the redundant cases which we have solved previously. So let's look at the code recursively. So what we do in this problem is to check all the cases. So if we have dice with k faces, then we can try all the k possibilities. So it should go from 1 to less than equal to k, and then increase I. And for each I, which is the possible outcome from one dice, we should check that if it is possible or not. If it is possible, then we can add it to our answer. And how do we get the get if we should add it or not? We should recursively call it for one less number of dice, because so num rolls to target n minus 1, k would remain same because number of faces aren't changing, and then target will reduce by I, because I is the outcome from one dice. Also remember we have to take mod here, so let's declare mod 9 plus 7, and after addition you can just take mod. Okay, now we can return the answer. And let's now write the base case. So what's the base case? Base case is when the number of dice is equal to 1, and let's say k is greater than equal to target, which means it is possible to get our answer from this one dice. Then we should return 1 because we are getting one possible way to get our target. And if it is not possible, that is when n equal to 1 and then k is less than target, then return 0 because there is no possible way to get that. So I think that's the base case. It's a recursive step. Let's try and check it on the cases here. Oh, we have to declare answer also. Okay, it's giving time limit exceeded because we have not memoized till here. So let's also try memoization. So I'll go on the lazy way of memoizing, that is using math. In this problem, what all variables are changing? That is n and target. So we should, for storing that state, we should store the value of both n and target. So let's memorize it. It will store the answer for n and target in this case whenever we ask the question, what is the answer for this particular n and particular target? This will store the answer so that whenever the case again arises. So when will it arise? When we write this is not equal to m dot end, then we need not to solve the problem, we can just return this pre-solved answer in this memoization table. Target. Okay, let's check it. It got accepted. Let's try on all cases. It got accepted. Thanks for watching.